C1 20 69. My name is Rouli with study number A1 C1 22057.
My name is Ulqairi Suita, study number A1 C1 22042.
My name is Imelda Siahaan, with study number A1 C1 22030.
My name is Kasidah Solin with study number A1 C1 2012 with stoichiometry material.
The following is a matrix of stoichiometry questions.
In this problem, we are asked to prove that when sodium chloride reacts with sulfur nitrate, a sulfur chloride precipitate will form, and we need to calculate the mass of the precipitate. First, we know the given data. The mass of natrium chloride is 1.5 gram, and the mass of sulfur nitrate is 0.2 gram. We are also given the relative atomic masses: silver 108, natrium 23, nitrogen 14, chlorium 35.5, and oxygen 16. The first step is to calculate the number of moles of each compounds of natrium chloride. The first calculate this molar mass, Mr. The Mr of natrium chloride is the sum of natrium and chlorium, which is 23 plus 35.5, resulting in 58.5. Therefore, the moles of natrium chloride equal the mass divided by the molar mass, 1.5 gram divided by 58.5, which is approximately 0.026 moles. Next, we calculate the moles of sulfur nitrate. The Mr of sulfur nitrate is silver plus nitrogen plus oxygen, which is 108 plus 40 plus 3 times 60. The given 120. So the moles of sulfur nitrate equal the mass divided by the Mr, 0.2 grams divided by 170, which is about 0.001 moles. After finding the moles, we were the balanced chemical equation. Sulfur nitrate plus natrium chloride product sulfur chloride plus natrium nitrate. This shows that sulfur nitrate reacts with natrium chloride in a 1:1 molar ratio to produce sulfur chloride and natrium nitrate. Now, to find the limiting reactant, we compare the moles since sulfur nitrate has only 0.001 moles, while natrium chloride has 0.026 moles. Sulfur nitrate will be completely used up first, so sulfur nitrate is the limiting reactant. Because the molar ratio between sulfur nitrate and sulfur chloride is 1:1, the moles of sulfur chloride formed will also be 0.001 moles. To find the mass of sulfur chloride, we multiply the moles by its molar mass. The Mr of sulfur chloride is sulfur plus chloride, which is 108 plus 35.5, resulting in 143.5. Therefore, the mass of the sulfur chloride precipitate is 0.001 moles times 143.5, which is equals 0.1435 gram. So, we have proven that this reaction will produce a sulfur chloride precipitate with heat 0.1435 gram. This calculation show how to determine the limiting reactant, apply the stoichiometry ratio, and calculate the mass of the product. To determine the name and concentration of the substrate remaining after the reaction, we first calculate the moles of each reactant. The oxalic acid solution has a volume of 100 ml and the concentration of 0.05 molarity, resulting in 0.005 moles. The calcium chloride solution has a volume of 100 ml and a concentration of 0.1 molarity, resulting in 0.01 moles. Next, we identify the limiting reactant by comparing the stoichiometry. The reaction is oxalic acid plus calcium chloride produce calcium oxalate and acid chloride. Based on the stoichiometry ratio 1:1, oxalic acid is the limiting reactant because it has fewer moles, 0.005 moles, than calcium chloride, 0.01 moles. Thus, all oxalic acid react completely with an equivalent amount of calcium chloride, leaving an excess of calcium chloride. The remaining moles of calcium chloride are 0.01 moles minus 0.005 moles. Together with 0.005 mole, the total final volume is 200 or 0.2 liter. So, the concentration of the lower calcium chloride is 0.005 moles, short 0.2 liter, together with 0.025 molarity. Therefore, the substrate left in solution is calcium chloride with concentration of 0.025 molarity. To prove the value of X in the hydrate compounds, we first determine the masses of the anhydrate salt and the water of crystallization. The total mass of the hydrate is 24 grams, while the mass of anhydrate alone is 12 grams. This means the mass of water is also 12 grams, 24 grams minus 12 grams. Next, we calculate the number of moles for magnesium sulfate with a molar mass of 120 grams salt malt. 12 grams corresponds to 0.1 mole. For water with a molar mass of 18 grams salt mole, 12 grams corresponds to 0.7 mole. The molar ratio between magnesium sulfate and water is therefore 0.1 salt 0.7. With 0 equals to 1 salt 7, hence the value or X in the hydrate is 7. To compare the percentage of carbon and oxygen in the sample, we first calculate the moles of carbon dioxide product. The volume of carbon dioxide gas collected is 896 milliliter, which is equivalent to 0.896 liter. At STP, 1 mole of gas occupies 22.4 liter. So the moles of carbon dioxide are 0.896 liter, such 22.4 liter such mole. Together with 0.04 mole from the combustion reaction carbon plus oxygen product carbon dioxide. The mole ratio shows that 1 mole of carbon products 1 mole of carbon dioxide. Therefore, the mole of carbon are also 0.04 mole. The mass of carbon is then 0.04 mole times 12 grams per mole, together with 0.48 grams. Given that the total mass of the sample is 1.2 grams, the percentage of carbon is 0.48 grams, so 1.2 grams times 100% together with 40%. Since the sample contains only carbon and oxygen, the percentage of oxygen is 100% minus 40% together with 60%. Thus, the ratio of carbon percentage to oxygen percentage is 40% or 60%, or simplified to 4/6. To determine the percentage of iron in a metal sample, we first calculate the moles of hydrogen gas product. The volume of hydrogen gas collected is 0.869 liter using the ideal gas law PV together with nRT, which P together with 1 atm, V together with 0.869 liter, R together with 0.092 liter atm such K mole, NT together with 300 Kelvin. The moles of hydrogen gas are N together with PV sorts RT together with 1 times 0.869 sorts 0.082 times 300 together with 0.035 mole. From the reaction, iron plus 2 hydrogen chloride product iron chloride plus gas hydrogen. The mole ratio of iron to gas hydrogen is 1:1, so the mole of iron are also 0.035 mole. The mass of iron that react is then 0.035 mole times 56 together with 1.96 grams. Given that the total mass of the metal pieces is 2 grams, the percentage of iron in the sample is 1.96 grams source 2 gram times 100% together with 98%. Therefore, after analysis, it is determined that the metal piece contains 98% iron.
Next, number 6 question is to compare the volume of C2H2 gas and O2 gas required in the combustion process based on the perfect combustion reaction equation. Answer: it is now reaction burning perfect gas acetylene C2H2 at O2 become CO2 at H2O not yet equal. Test done on pressure steel and temperature steel. Law-Gay-Lussac applies. Gas volume ratio, coefficient ratio. Asked comparison volume gas C2H2 compare gas O2 which required in burning perfect. Answer: equality reaction 2C2H2 at 5O2 become 4CO2 at 2H2O. Understand comparison volume according to Law-Gay-Lussac on temperature and pressure steel. Volume gas proportional to the coefficient in the balance reaction. Coefficient C2H2 together with 2, coefficient O2 together with 5. Fifth comparison, the coefficient that unit C2H2 and O2 that is 2 compare 5. So the ratio of the volume of C2H2 gas and O2 gas in perfect combustion is 2 compare 5. Next question is proof with calculation that the iron ore that required to obtain this amount of iron is 320 tons. Answer: it is now mass of pure iron to be produced together with 224 tons percentage content Fe2O3 in or iron together with 80% Ar, Fe 56 AO together with 16 reaction reduction Fa2O3 at 3CO become 2Fe at 3CO2. Asked prove it with calculation how many ton or iron is required to obtain the amount of iron. Answer: Fe2O3 at 3CO become 2Fe at 3CO2 and Fe together with 224 grams by 56 grams by mole together with 4 and Fe2O3 together with 80 by 100 times mole Fe together with 80 by 100 times 2 mole together with 1.6 mole mass Fe2O3 together with 1.6 mole times 160 gram by mole together with 256 gram mass Fe together with 256 gram times 100 by 80 together with 320 ton. So has proven that all iron which required for to obtain amount the iron is 320 ton. Next question: describe the step needed to determine the number of helium atoms contained in 10 liters of helium gas at the same temperature and pressure. It is now setting Avogadro together with 6 times 10 to the power 23 and together with 14. Answer: step 1. Determine what gas which now in question. Mass gas nitrogen together with 5.6 grams, volume of nitrogen gas together with 5 liters, mR gas nitrogen together with 2 times 14 together with 28 gram by mole, volume of helium gas together with 10 liters, setting Avogadro together with 6 times 10 to the power 23. Atoms by mole temperature and pressure are the same. Step 2. Determine what gas which asked in question. Describe in each step which required for determine amount atom helium contained in 10 liters of helium gas. Step 3. Count amount mole gas N2. Mole N2 together with mass by mR together with 5.6 grams by 28 gram by mole together with 0.2 mole. Step 4. Determine volume molar gas because 0.2 mole gas N2 occupy 5 liter, so volume per mole together with 5 liter by 0.2 mole together with 25 liter by mole. Step 5. Count number of moles gas He in 10 liters. Mole Xe together with volume by volume per mole together with 10 liters by 25 liters by mole together with 0.4. Step 6. Count free day atom He. Number of 8 E atoms together with 0.4 mole times 6 times 10 to the power 23 atoms by mole. That's it step which use it for determine amount atom He with the final result being 2.4 times 10 to the power 23 atoms. Next, in this question, we are asked to detect the percentage of sulfate contained in the sample. Answer: it is now mass sample sulfate together with 0.1471 grams, mass sediment which obtained together with 0.2329 grams. Asked detect its level percentage sulfate which there is in sample. Answer: ABA together with 137, ARS together with 32, ARO together with 16. BI to the power plus at SO4 to the power 2 mean become BISO for percentage mass of sulfate together with MrSO4 times mass of precipitate by mass of BISO4 times mass of sample times 100% together with 96 times 0.2329 by 233 times 0.1417 times 100% together with 65.23%. So after detection, the percentage of sulfate contained in the sample was 65.23%. Next question. Describe the step to find out the relative atomic mass of element X based on the available data. Answer. Step 1. Determine what just which now in question. Mass of gas X2 together with 2 grams. Volume of gas X2 together with 1 liter. Mass gas C2X6 together with 7.5 gram. Volume gas C2X6 together with 10 liter. Mr C2X6 together with 30 gram by mole. Temperature and the pressure is the same for both gas. Step 2. Determine what gas which now in question. Describe step 4 now how many mass atom relative element X based on available data. Step 3. Count mole gas C2X6 this question and C2X6 together with 7.5 grams by mole, 30 grams by mole together with 0.25. Step 4. Since the temperature and pressure are the same, the law applies comparison of volume and moles. Avogadro. N1 by V1 together with N2 by V2. N2 together with 0.25 mole times 1 liter by 10 liter together with 0.025 mole. Step 5. Count Mr mass molar gas X2. Mr X2 together with mass X2 by NX2 together with 2 grams by 0.025 mole together with 80 gram by mole. Step 6. Count A element X because gas X happens X2M. 2 X2 together with 2 times ARX 80 together with 2 times AX. ARX together with 80 by 2 together with 40. These are the steps used to determine the relative atomic mass of element X with the final result being 40.
In this question, we will prove that the volume of hydrogen gas can be used to solve the problem of zinc levels in a sample. This question, step 1, H2 SDP equals 11.2 equals 0.0112 liter. M equals V slash 20.4 equals 0.0112 liter slash 22.4 equals 0.005 mole. Reaction Zn plus 2HCl to produce ZnCl2 plus H2. M equals times AR equals 0.005 mole times 65 equals 0.0325 grams. Percent Zn in the sample equals mZn slash m exceed times 100% equals 0.0325 slash 1 times 10 equals 3.25%. And the zinc content in the footage is 3.25%. In this question, namely detecting the levels of Cl ions in seawater, sample be analyzing the mass of AgCl precipitate format. Discussion. V seawater equals 10 ml to produce 10 equals 1.025 gram slash milliliter. Rho equals m slash V equals rho times V equals 1.025 gram slash milliliter times 10 milliliter equals 10.25 gram. AgCl equals 29.7 gram. And AgCl equals m slash mr equals 28.7 slash 143.5 equals 0.2 mole. Cl mean plus AgNO3 to produce AgCl plus NO3 mean. MCl mean equals n times AR equals 0.2 times 35.5 equals 7.1 gram. Percent Cl mean equals mass Cl mean slash seawater mass times 100% equals 7.1 slash 10.25 times 100% equals 70%. So the detection result found in the Cl ions level are 70%. In this question, we are asked to prove that the value of X in the compound MnO3X is greater than 1. Discussion. Mole AgCl equals gram slash mr equals 7.175 slash 143.5 equals 0.05 mole. Exists AgNO3 added in 2.5 times 10⁻². moles of MgLX as a limiting reagent coefficient comparison to mole comparison. AgCl mole comparison to MgLX close 0.05 to 0.025 equals 2 to 1. 2 AgNO3 plus MgLX to produce 2 AgCl plus MnO3X. Possible reaction 2 AgNO3 plus MCl2 to produce 2 AgCl plus MnO3 2. So, it is proven that the value of H formed in the compound MnO3X is greater than 1, namely 2. Discussion, step 1 now. Equals CO2 gas equals 0.1. ARCA 40, ARC 12, and ARO equals 16. As CaCO3 sediment mass. Answer, CaOH2 aqueous plus CO2 gas to produce CaCO3 gas plus H2O liquid. And CO2 equals 0.1 mole. And CaCO3 equals 1/1 times NCO2 equals 0.1 mole. Mass CaCO3 equals NCaCO3 times molar mass CaCO3. Mass CaCO3 equals 0.1 mole times 100 gram/mole equals 10 gram. In the question is detect how many liters of CO2 gas volume are produced in the SDP state. And CaCO3 equals 30/40 plus 12 plus 3 times 6 equals 0.3 mole. And HCl equals 6.72/22.4 equals 0.3 mole. CaCO3 solid plus 2 HCl gas to produce CaCl2 aqueous. After this calculate, we get VCO2 SDP equals N times 22.4 liter equals 0.15 times 22.4 liter equals 3.36 liter.
In a measurement, a student gets data that 5 liters of gas X has a mass of 11 grams. He knows that MR gas X is 44. To test the consistency of the data against the ideal gas theory, prove that the molar volume of gas X under this condition is different from the molar volume of gas X. Molar standard 22.4 liters per mole on S.Pd and explain meaning scientifically based on the ideal gas principle in relation to the effect of temperature. Answer, no. Volume gas X equals 5 liter. Mass gas X equals 11 gram. FR mass molecule relatively gas X equals 44 gram per mole. Volume standard on STP equals 22.4 liter per mole. Asked, prove that the molar volume of gas X under this condition is different from the molar volume of gas X. Standard molar and explain is scientific meaning based on the ideal gas principle in relation to the effect of temperature and pressure. Discussion, called mole gas X. Mole equals gram per mass molar equals 11 grams per 44 extent gram per mole. Asked, describe its step calculation stoichiometry, which can use it and give an assessment of its accuracy and consistency. Discussion, step calculation stoichiometry, we can use it for determining the mass of water produced from the combustion of ethanol is 1. Weight and balance the reaction equation for combustion of ethane. In a measurement, a student gets data that 5 liters of gas X has a mass of 11 grams. He knows that MR gas X is 44. To test the consistency of the data against the ideal gas theory, prove that the molar volume of gas X under this condition is different from the molar volume of gas X. Molar standard 22.4 liters per mole on STP and explain meaning scientifically based on the ideal gas principle in relation to the effect of temperature. Answer, no. Volume gas X equals 5 liter. Mass gas X equals 11 gram.
Mr mass molecule relatively gas X equals 44 gram per mole. Volume standard on S.Pd equals 22.4 liter per mole. Asked, prove that the molar volume of gas X under this condition is different from the molar volume of gas X. Standard molar and explain is scientific meaning based on the ideal gas principle in relation to the effect of temperature and pressure. Discussion called mole gas X. Mole equals gram per mass molar equals 11 grams per 44 grams per mole equals 0.25 mole. Count volume molar gas X. Molar equals mole gas per volume gas equals 0.25 mole per 5 liters equals 20 mole. Count volume molar gas X. Molar volume equals mole gas per volume gas equals 0.25 mole per 5 liters equals 20 mole. Based on result calculation, obtain volume molar gas X as big as 20 liter per mole. Mark this is different from the standard molar volume of 22.4 liter per mole at the S.Pd. This difference indicates that gas X is likely at the higher pressure of lower temperature than at standard condition. This shows that change in temperature and pressure can affect the molar volume of a gas, as explained by the ideal gas law. Therefore, understanding the effect of physical condition is essential to avoid misinterpretation of measurement results. Asked, describe its step calculation stoichiometry, which can use it and give an assessment of its accuracy and consistency. Discussion, step calculation stoichiometry, we can use it for determining the mass of water produced from the combustion of ethanol is 1. Write and balance the reaction equation for the combustion of ethanol. Alpha hydroxide plus 3 or right flooding 0 to carbon dioxide plus 3 SL. 2. Determine the mole water which produced. From this equation, it is known that 1 mole of ethanol produces 3 moles of water. So if 0.2 mole of ethanol is burned, the water produced is 0.2 times 3 equals 0.6 moles of equals 0.6 moles of hydrogen sulfide. 3. Check mole water becomes mass water used ml hydrogen sulfide equals 18 gram per mole. 0.6 times 18 gram per mole equals 10.8 grams water. Therefore, if there is an error in balancing the reaction such as writing that a mole of ethanol produces only 1 mole of water, then the calculation result will be wrong. And it deviates far from the values they should be. Likewise, if the mole ratio between substances is not considered or the conversion of moles to gram is done incorrectly, then the mass of water obtained will not be accurate. 19. Carbon to solvent decider is hydrated compound commonly used in chemistry experiment to determine the number of water molecules in it. In an experiment, a student heated 2.5 grams of the compound until 1.6 grams of endurous solid remained. Answer: no, must beginning carbon to solvent decider equals 2.5 grams. 20. Calcium carbonate is compound often used in thermal experiments to observe the thermal decomposition process. In an experiment, 20 grams of calcium carbonate is heated until it completely decomposes into calcium oxide. The step needs to determine the volume of carbon dioxide gas in liters produced at S.Pd standard temperature and pressure condition. Answer: to determine the volume of carbon dioxide gas produced when 20 grams of calcium carbonate completely decomposes. The steps are as follows. 1. Write equality reaction with equivalent chemically. K3H KOS plus KO2G. Equality this shows that 1 mole KO3 produces 1 mole K2 when perfectly decomposed. 2. Count mass molar ml KO3. ml KO3 equals ARCA plus ARC plus 3ARO equals 40 plus 12 plus 3 times 16 equals 100 gram per mole. 3. Determine Molich process. Based on the reaction equation, 1 mole of KO3 produces 1 mole of KO2. Therefore, 0.2 moles KO3 will also produce 0.2 mole of KO2. 0.2 mole of KO2 count KO2 volume on S.Pd condition 22.4 on condition S.Pd 0 degrees Celsius 1 atm. 1 mole gas ideal occupy 22.4 liter.
The question of 21. A student conducted a reaction between 5 grams of magnesium metal or Mg and excess hydrochloric acid or HCl. The reaction is as follows. Mg plus 2 HCl turning MgCl2 plus H2. The result showed that only 150 ml of H2 gas was produced at STP. Please prove whether the experimental result is consistent with theoretical calculations. If not, calculate the percentages. Okay, let's discuss it. The first, calculating moles of Mg. Relative mass Mg is equal to 24 moles is equal to 5 divided by 24 is equal to 0,208 mole. Furthermore, theoretical moles of H2. When 1 mole Mg equals 1 mole H2. Where 1 mole Mg is 0,208 mole. So 1 mole Mg is equal to 1 mole H2 is 0,208 mole. Furthermore, theoretical volume of H2 is STP. 3 is equal to moles multiplied 22,4 is equal to 0,208 multiplied by 22,4 is equal to 4,69 liters is equal to 4,660 milliliters. Actual yield versus theoretical yield. When actual yield equals 150 milliliter, percentage yield is equal to 150 divided by 4,660 multiplied by 100%, approximately 3022%. The experimental result is much smaller than the theoretical value. This may be due to gas leaks, incomplete reactions, or equipment not being right. The chemistry teacher challenged the students to design a simple experiment in the laboratory to prove that the mass of a substance does not disappear in a chemical reaction. The students were provided with materials, sodium carbonate or NaCO3 and hydrochloric acid or HCl. Okay, the first step is the experiment design. Weigh the empty element box and record its mass. Step 2. Add HCl solution into the element flux, then weigh it again. Step 3. Prepare an NH2CO3 powder in a small test tub. Place it into the Erlenmeyer without mixing it first. Step 4. Seal the Erlenmeyer flask tightly with a balloon or stopper. Weigh all the equipment and materials or initial total. Step 5. Gently shake until the reaction occurs. And NH2CO3 plus 2HCl turning to NaCl plus CO2 plus 2H2O. The last step after the reaction is complete, weigh all the equipment again or the final mass. If the mass does not change, then the law of conservation of mass is proven. If it decreases, it means that some CO2 gas has escaped or the equipment is not alright. Next question, a student conducts an experiment by burning ethanol in a closed laboratory to determine the volume of carbon dioxide produced. He completely burns 49 grams of ethanol. The reaction equation is C2H5OH plus 3O2 turning to CO2 plus 3H2O. Compare the relationship between the number of moles of reactants and product in the context of the law of defining proportion. Calculate the moles of ethanol burned and calculate the moles and volume of CO2 produced under STP conditions. Okay, let's discuss it. First, calculating relative mass of ethanol is 49. When mole is equal 49 divided by 49 is equal to 1 mole. Second step, calculating moles and volume of CO2. When 1 mole ethanol produces 2 mole carbon dioxide, is volume CO2 equal to mole multiplied by 22,4 liter is equal to 34,8 liter. The reaction shows that the constant mole ratio between ethanol and carbon dioxide is 1:2 according to the law of the constant proportions. Okay, the next question. Body reacted 6,5 grams of zinc with excess hydrochloric acid and collected hydrogen gas in the lab. The reaction took place at STP, Zn plus 2HCl turning ZnCl2 plus H2. The gas produced and collected was 2 liters. Calculate the theoretical volume of hydrogen gas and compare it with the actual volume of the reaction carried out by body. Okay, let's discuss it. The first, calculating moles Zn. When relative mass of Z equal 65, mole Z is equal to 6,5 divided by 65 is equal to 0,1 mole. When 1 mole Z produces 1 mole hydrogen gas. Furthermore, calculating theoretical volume. When theoretical volume equal 0,1 multiplied by 22,4 is equal to 2,24 liter. Actual volume is 2 liter. So 2,24 plus 2 is equal to 0,24 liter. So the actual volume of hydrogen gas collected by body in the laboratory was only 2 liters. This means that the actual result less than theoretical result. This comparison occurs because of the chemical reaction does not take place perfectly. There is hydrogen gas that escapes and is not perfectly contained in the collection device, for example due to a leak in the device or a less tight storage system. Maybe even though hydrochloric acid is in excess, the reaction may not take place up to 100% conversion due to insufficient reaction time or the addition of impurities that inhibit the reaction, or errors in measuring the mass of zinc, inaccuracy in reading the gas volume, or environmental conditions that deviate slightly from STP, such as room temperatures higher than 1 degrees Celsius, which cause the gas volume to expand so that the reading is accurate. Question. A student conducted a complete combustion experiment on 11,2 grams of propane. The reaction took place in a closed room with excess oxygen supply. The reaction equation is C3H8 plus 5O2 turning 3CO2 plus 4H2O. The student wants to know whether the carbon dioxide gas results obtained are in accordance with the theory. Compare whether the mole ratio is in accordance with the experimental result if the actual CO2 volume is only 20 liters. Calculate the moles of propane burn and determine the volume of carbon dioxide produced at S.Pd. Okay, let's discuss it. The first, calculate the mole C3H8. When relative mass of propane is 44. So, mole of propane equal 11,2 divided by 44 is equal to 0,2545 mole. Furthermore, calculating the moles of propane burn and determine the volume of carbon dioxide produced at S.Pd. From the reaction obtained, 1 mole propane equal 3 mole carbon dioxide. 0,2545 mole equal 0,2545 multiplied by 3 is equal to 0,7636 mole of carbon dioxide. So, volume of carbon dioxide is 0,7636 multiplied by 22,4 is equal to 17,1 liter carbon dioxide. So, actual volume is 20 liter greater than theoretical volume is 17,1 liter. So, possibility the effect of temperature and pressure that are not at S.Pd conditions. If the reaction chamber temperature is higher than 1 derajat Celsius or the pressure is lower than 1 atm, the gas will expand, producing a volume greater than that calculated assuming S.Pd. Or the gas volume meter is not calibrated properly or has systematic errors. The recorded volume might be greater than the actual volume. Maybe the presence of other gases that are measured together with carbon dioxide, such as water vapor that is not fully condensed, or residual oxygen that is trapped in the measurement system, increases the total volume recorded.